the Brown Pundits BrownCast.
Hello and welcome to another episode of Brown Pundits BrownCast. My name is Maneesh Taneja. This is the second episode in our series of podcasts on the history of the Indian subcontinent. We take a detour in this episode and talk about one of the methods of studying ancient history. Over the last few years, genetics and the study of the ancient DNA has helped us understand where we come from. Razib Khan, one of the co-founders of the Brown Pundits blog and the BrownCast, does that. He studies genetics and now has a Substack where he tells us about our ancestors from the lens of our genetics. In this episode, Razib talks to us about how the science of genetics is helping us understand our ancestry. Joining me in this conversation are Shrikantha Krishnamachary, Gaurav Lele, and Mukunda Raghvan, who makes his debut on this series. Welcome to the episode, gentlemen.
Hey.
Right, since Rasib and Mukunda, this is the first time we are having you on the series. If you could just start with a short introduction and tell us something about yourself. What is it about history that gets you all excited? The first history book that got you hooked, and your favorite history trivia. We start with you, Rasib.
Go ahead, Razib. All you, buddy.
So I'm Razib Khan. I'm a geneticist and a history buff. Run a couple of blogs. I run a Substack. I think the first history book was like the Children's History of the World. It's a really old book. I think it dates to the 1930s. I got a reprint edition in the 80s, and it just covers the whole world, and it was super interesting to me. And in terms of trivia, perhaps interesting point of trivia is the battle that saw the Zhao dynasty defeat the Shang dynasty in 1100 something BC in China. We have an exact date for because it's correlated with particular astronomical signs that we can estimate. So we have really good precision for that dynastic handover in the late Bronze Age.
Wow, that's nice. Thank you for that. Mukunda.
Yeah. So I guess I'm a lawyer. I'm based out of Los Angeles. I joined Brown Pundits, I guess a couple of years after they started their podcast. I used to listen to them all the time, and one day, like Razib and I wanted to do a podcast with these guys. We did it, and then I kind of just asked Razib and Omar if I could help with the podcast, and we kind of just jumped in, and I kind of started, I think, in 2018 with them. And my background is I'm a lawyer. Or I don't really practice anymore, but I do have my licenses. I kind of run a tech company, and related to a tech company also in India. So I I'm in my work life. I'm a jack of all trades, so to speak, and I think that kind of applies also to my academic interests. I kind of triple majored in college, and then I did my master's, which I didn't finish, in Western philosophy, continental philosophy, along with my law degree. And then kind of my larger interest in history started probably, honestly, when I was 15, probably 15, when I started really studying law and government, and its history in high school. It was mostly the high school textbooks, but what really started my deeper interest was when this is a tangential like book, was Bullfinch's mythology. I really, really was fascinated by the mythology of the Greeks, and that kind of really started me on the line of trying to understand, where does literature and culture and art and human thought play a role in human history, and what is it coming to be? And then, so as part of studying philosophy, right, you have to understand historical figures, and in what time frame and cultural milieu they existed, so that we can better put context into their thoughts and what their thoughts came from. Right, like whether we think about Plato or Aristotle, we can understand some of their thoughts because of the historical context. And so I spent, I guess, most of my college and law school career just really studying how these thoughts came into being, in the cultural context. Right, like if you look at law, the entire basis of law and the history of legal thought, and even the United States Constitution, and the way we conceive of issues in law, and even the reasoning is based primarily upon the time, place, and situation, and the way people's interests and their major concerns existed at that time. So yeah, I mean, when it comes to Indian history, I would say it really started with college. In college, I used to go to the library a lot in between classes, and I would just basically rent books and sit in the library and read books all like that were not part of my subjects that I was studying at the time, because I thought it was fascinating. Um, and then, obviously, in the Indian context, I read Basham, like you guys mentioned last time. I did enjoy that, but I really liked a lot of the Indian authors separately, like whether it's R. Sharma or A.S. Altkar, or any of these like older writers, historians. I thought they were really fascinating because they offered interesting insight. But then when I started to think about like their cultural way they approached the lens on how to view everything through a Marxist kind of lens, it put into my thought process that I find that most history making is from a particular lens, which may or may not be true, but we have to discuss its underlying presumptions and premises to understand if they make sense from a theoretical point or even with the data that we currently have. So, yeah, I mean, that's a long winded answer. So, yeah.
Right, thanks for that. And yes, all history teaching, in my opinion, is basically history teaching through a particular ideology. And the whole idea of this project of doing this history podcast is to get history buffs and history geeks to talk about history, hopefully without the blinkers of ideology. So thank you for that. Razib, I'll start with you with the idea of trying to understand how do we study a time and people who lived 4,000 years ago. So, if you could just tell us, how do we trace the ancestry of present day people with genetics? How does the process work?
Yeah, there's two major ways that you do this. The one major way, the older way that was amenable to the technology at the time, is old, like 20 years old actually, so it's not that old. Is you look at the genetic variation in modern populations, you construct a family tree, you put individuals in that family tree, and then construct models of how the family tree emerged. And then from those models, you can draw some conclusions. So, for example, if you construct a family tree of all humans, you see all people outside of Africa are in a branch together, separate from all people within Africa. And so the inference that you can make is okay, this is the deepest division in the human history and human prehistory. And then you look at the individuals that are African and not African, and you see the Africans are more genetically diverse. That in fact, it's not just two different branches, but the non African branch is a sub branch of the African tree. So, from this conclusion, paleoanthropologists and geneticists make the inference that we all left Africa X number of years ago. How do we determine that? You use paleoanthropology, paleontology. You can see when the particular type of tool started spreading very rapidly 60,000 years ago. And now you also have methods called like the molecular clock, where you have a certain mutation rate, certain number of generations, and then they coalesce back to common ancestors, and you can construct a tree of when the diversification. You can reverse the tree. So the tree is forward history, and then you can do reverse by taking the tips of the tree and then inferring backward. And so that's the sort of thing you do in the generality. In the specifics with the Indian subcontinent, the initial thing that people noticed 20 years ago is people of subcontinental origin are positioned just where you would kind of think geographically. They're between East Asians and Europeans and West Asians, a little closer to Europeans and West Asians, depending on the population. So people in Pakistan, people in upper castes tend to be closer to West Asians. And then people in South India, people in lower castes tend to be closer or in the middle to East Asians compared to East Asians. And then you have people in the Northeast who are closer to East Asians in general, depending on what ethnic group they are. And so people were drawing certain conclusions from these positionings in the family tree. And then what a group of researchers at Harvard, David Reich, Nick Patterson, did in 2009 is they said, okay, well, we can see the whole genome. We can extract a lot of information from it. And from the whole genome, we can actually tease apart mixing phenomenon. And so basically, what paleontologists, paleoanthropologists, and paleogeneticists have figured out is actually it's not a family tree, it's more like a lattice. And there's a lot of gene flow between different populations to create new, secondary, tertiary, quaternary populations. So you can do this with almost every population. There are actually fusions of 2, 3 ancestral populations as you go back. So not only does the tree converge at some points, it also bifurcates. And it turns out that Indian populations could be modeled as a mixture of, at minimum, two populations, one that's closer to people in East Asia, Southeast Asia, and they used Andaman Islanders as a proxy for that. Andaman Islanders are not actually ancestral, they're still around, but they diverged 20, 30,000, maybe 35,000 years ago from this ancient population that's in the eastern part of Eurasia that's ancestral to a lot of Indian heritage. And then the other part of the ancestry was much more like people in West Asia and Europe. And I actually talked to Nick Patterson, who's a statistical geneticist developing the method. He said when you split the two parts apart, the one that's not like West Asians and Europeans, that doesn't really have close ancestors or close relatives anywhere in the world, even though it's closer to East Asians. Probably diverged, like I said, 30 to 40,000 years ago from other populations in Eastern Eurasia. But the one that's like West Asians and Europeans is actually genetically pretty close to a lot of these West Asian and European populations. It looks like it diverged from them very, very recently. So it's as genetically far from a random European as a Finn or a Sicilian is are from each other. So it looks like a contemporary population, that could be out there. So that was what they found about 10 years ago, actually like 12 years ago now, almost 13 years ago. And then in the teens, in the 2010s, what people started realizing is, okay, so we can have the tips of the tree, of the family tree, these modern populations, we can sequence them, we can genotype them, and then construct models to fit the data. But now we can actually use ancient DNA, go into the nodes of the tree. So go back into the tree, and instead of making an inference, an estimation, you could actually get the real value by sequencing the ancient DNA. And so they start to do that all over the world. I have a multi-part series of my Substack coming out about British history. They actually have 598 ancient genomes from Britain, from 10,000 years ago uh, to down to the Roman period. So that's more genomes that existed in the world in 2005, like modern, right? So some places have really, really thick density of ancient DNA. India does not. But we have Rocky Gari, and then we have samples in Afghanistan, border areas of Iraq, Tajikistan, that have genetic signatures that are very much like Indian subcontinental. They're not like typical West Asians. And basically, what the Reich lab started doing was try to fit this ancient DNA, and even a few samples can really resolve your tree because it takes the confidence intervals in the internal nodes and it resolves them. In terms of there's no confidence interval. You have the ancient genome, you don't need to make an inference. And so you snap that position in the tree, in the lattice, you resolve it, and so it adds a lot of clarity. So Vagish Narasimha, the first author of the Reich Lab paper from 2018 now, I think, when they got the Rakhigarhi genome, and this dates to about 4,300 years ago. He told me, he said, "Oh, I knew that this was not contamination. This was not contamination from any worker because it doesn't look like any human alive today." This individual does have commonalities with a lot of people in the Indian subcontinent, but there are aspects of the genome that just look nothing like anyone alive today, which means it's probably not contamination, right? And so what they discovered is the West Asian European ancestry of Indian subcontinental people can be divided into two components. And actually, this was not surprising. I actually started looking at the data myself in 2010 with a lot of other people, and I told Nick Patterson and David Reich, I said okay, this ancestral North Indian component that you have, there's no way that it's one single component. If you create these models, it shows that it just splits apart all the time. And the variation, say in Pakistan, is like in Balochistan, there's one component that's really high frequency, excuse me. And then when you go to the northern part, there's another component that's high frequency. And it was pretty obvious to a lot of us at the time that this had something to do with Indo-Aryans and steppe migration or something like that, because there's certain groups that had a lot of steppe ancestry and certain groups that didn't. So, for example, Brahmins in Bihar had a lot more steppe ancestry than people in southern Sindh, even though people in southern Sindh had more ancestral North Indian ancestry. So, the math can't work out unless there's actually two components there, right? So there's three components is what they're inferring now. There's one that's ancient ancestral South Indian, which is very, very different from anything else in the world, but it's more close to, say, Andaman Islanders, the ancient Paleolithic people in Southeast Asia, and to a lesser extent East Asians in general, East Eurasians. And then the other component is split into this steppe ancestry, and they have hundreds of samples from the Eurasian steppe now. Like the Santashta people are the best proxy for it. They carry the Y chromosome that's found in 25% of people in the Indian subcontinent. The exact Y chromosomal lineage is found in about 90% of Santashta men. They carry the ancestral mix that's inferred to be this steppe ancestry. Now, the Rakhiari woman has none of that. And this steppe ancestry is found at low levels pretty much in all Indian populations, low to high levels, right? Except for a couple of South Indian Adivasi tribal groups who have no steppe ancestry. So the Puliyar, that's one example. Pania, there's a few others you can name. But in general, most populations have say 0 to 5%. And then you have certain groups like Jats and North Indian Brahmins who have 30% steppe ancestry. So that's the range. So the Kalash, the Jats, North Indian Brahmins are at 30%. And then, the average peasant in UP, whatever, just random draw, it's going to be about 15%. You go to South India, it goes to 5 to 10%. And then it goes to 0 in a few populations, right? The final component is basically something indigenous to the Indus Valley civilization that seems to be, I would say, moderately related, not distantly or closely, to the pastoralists of Western Iran, but they diverged from them sometime in the late Pleistocene, so 10 to 15,000 years ago. They're somewhat genetically different from them, actually. They don't have affinities with farmers from the Levant, like Natufians or Anatolians at all. So they seem to be isolated from that gene flow, and there's some gene flow from southern Siberia into these peoples. And that's actually, in a lot of Indian groups like Sindhis, Patidars, just a lot of most Indian groups, not most, probably half. That's the largest component, actually. So it's some sort of let's call it quasi-Iranian, because we don't know, we don't know where and when it came from, because we don't have quote pure samples, because they're Rakhiari woman and a few of these Indus Valley civilization samples, they're on the order of 70 to 90% this component, but there's no one that's 100%. There's no one that's 100% ancient ancestral South Indian, which is the other component. There's no samples, right? So there's only so much we can say about it. With the steppe, there are people who are 100% steppe. Like the Santashta people are perfect proxies for that. So the final thing I'll say is, in terms of 4,000 years, 3,000 years, all of these timings. So they had, for various political reasons, India is just extremely slow with biological science. So a lot of this stuff is discovered in Pakistan because they're much more liberal about letting people actually do research. Okay, this has been true since the 1970s. It's just a fact, right? So they took a bunch of DNA samples from the Swat Valley that date back to 1000 BC. And what they see is, one, you can see that the basically the Indus Valley component starts out really high and it keeps dropping over time into the modern era. And the other thing that's happening is the steppe component keeps going up, but so does the ancient ancestral South Indian component. And so they become much more like Indians of the rest of the subcontinent over time. And so I think what's happening here is they're getting integrated into the broader, subcontinental milieu. And what you can do is, looking at the samples from 1000 BCE, you can look at the pattern of the segments, because the segments are broken apart over time through recombination, and you can step back in terms of when did the segments mix in from these disparate populations. So that's why they're getting an estimate of, say, I think 1800 BC, 800 years before. It looks like you could separate out the two segments, and that's when the steppe component starts mixing with the Indus Valley component. And so that's what happens first. And then this combined component starts mixing with the ancestral South Indian. Now, the Indus Valley itself has some residual ancestral South Indian. It's there already. So if you look at the Kalash, they're used. The Reich Lab estimates that they're basically the same ancestral mix as ancestral North Indians, about 30% steppe, about 70% Indus Valley component. But that Indus Valley component has within it a minority ancestral South Indian, ancient ancestral South Indian, just to be clear. So that's mixed in twice. And so there's initial mixing in the Indus Valley civilization where you have individuals that are 10% to 40% ancient ancestral South Indian. That's the range we see in these ancient samples from Afghanistan, Iran, and Tajikistan. And then there's like a secondary migration wave later that mixes with unmixed people that are ancient ancestral South Indian and South and East India. And so that increases the fraction in a lot of people. So the maximum fraction would be in the Puliyar that are 70% ancient ancestral South Indian from the second wave of mixture. And then their 30% of their residual ancestry is Indus Valley civilization type ancestry, which itself has a bit of ancient ancestral South Indian. So their estimate is closer to 75%, right? And so like this is the way that you conceptualize it. You have a 3 population model and the mixing happens in sequence and it's getting resolved through a combination of contemporary samples and also ancient DNA. And what I do is people often ask me like, "Oh, could you like estimate my genome?" I just put their genome through the model and I just pop out percentages, right? So I can tell you your step percentage, your IVZ percentage, your ancient ancestral South Indian percentage, based on certain parameters in the models. Try to like keep the parameters, the same with a certain like population history that we know from the literature, and so that's how we do it. Yeah.
Right, thanks for that. Before I get into a broader question, how do we gather ancient DNA?
Yeah, there's a bunch of different ways. They've really improved over the last 15 years. So one of the best ways now is there's a particular bone in the inner ear, and that bone is extremely dense with DNA, and the inside of it, and it's also sealed. And so what they found is if you can find that bone, you can extract a lot of ancient DNA. There's other things like the inside of teeth. I think that's obvious why that would preserve well. DNA itself is a robust macromolecule. It doesn't degrade very fast. Like RNA degrades really fast. This is why you don't have to worry about RNA vaccines, PSA. But DNA is a very robust molecule. It doesn't degrade fast. It takes a while. So it's going to be there. Basically, the oldest DNA that we've gotten so far is from 900,000-year-old horse in Siberia. But, people have gotten DNA, like now 8,000-year-old DNA from a rock shelter in Cameroon, like in the tropics. So they're getting really good at it. So you get the target, you enrich basically with these tags that are searching for human DNA because it's mostly bacteria, and you don't want the bacteria stuff. So you don't amplify the bacterial stuff, the contamination. You enrich the human stuff, and then you amplify it, which means you make copies of it so you can analyze it. And then they look at the DNA, and DNA basically it degrades and it's not really mutation. I don't want to use the word mutation, but the molecules change in a very specific way based on how old they are. And so if it doesn't look like the molecules are changed, it's contemporary contamination. But if it looks like the molecules have changed in terms of particular macromolecular changes, you know that it's ancient DNA. And then once you know it's ancient DNA, you have some algorithms that fix the molecular changes in the model when you're extracting out the data. And so you can reconstruct genomes of ancient people by, fixing these problems that happen with degradation. And you can extract that from particular parts of the human body that are highly rich in DNA and also relatively sealed off from the outside world.
Right, thanks. A comment. So, what we are saying is that the subcontinent has had now, we can go back and trace through DNA, genetics, uninterrupted civilization of about over 4,000 years. And over these 4,000 years, there has been a mixing of people who were what you would call the ASI and the steppe DNA and also the Indus Valley DNA. Would that be the right submission?
Yeah, so I think another thing that you need to say is the IVC, they themselves are a mixing event, and so they mixed earlier, and it's harder basically. it's easy to get the last major mixing in these statistical analyses with like contemporary DNA samples, which is what you can do, or with DNA samples that are after the mixing event. But there's earlier mixing events. There's one between the IVC and the ancient ancestral South Indians. Really, there's an earlier mixing. The estimates they used, I don't want to get into it. They used a somewhat different method, more advanced method, and they got, I think, like 6,000 to 7,000 years, something like that, like 6,000 years, 5,000 to 6,000 years. It's like thousands of years earlier than the classical IVC. So there was an earlier one before the steppe people arrived, where it's like, who was living in the Indus Valley and in eastern Iran mixed with people that were expanding out from South and East India. I mean, you guys need to remember that during the Pleistocene, India was actually considerably drier than it is today. So there, and the Thar Desert was bigger and more intense. So that's why there's this huge division between East and West in Eurasia. The center of Eurasia was extremely hot and dry. And then after the Pleistocene, after 12,000 years ago, it became much more habitable depending on where you are. And so there started to be more connections and gene flow. And this is what we're seeing in the Indian subcontinent. The boundary between West and East Eurasia, in a way, kind of shifted eastward as people from the West kind of moved into the subcontinent and started mixing with people.
Hey, so Razib, I would have a follow-up question to you on this. So what's the number of data samples that we have to start extrapolating DNA from in that period of time of not the first mixing with Iranian pastoralists, but the second mixing with the steppe people, and also like how 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 dispersed is that data set? Is it just from one particular region? Is it from multiple regions? And how many do we have of that? Do we know?
Yeah. So I think we have like, don't quote me on this, but or actually do quote me, I guess. But I think we have like around 20 from the Swat Valley, and then there's like random odds and ends you can, because there's like, I think there's like a clear Indian individual in Tajikistan, like 500, no, like 1500 BC. Like the individuals, like clearly not indigenous, they're Indian. They're just like a random sample in Tajikistan. So you have to add that. There's other like random samples. So I think like a couple of dozen ancient ones is what you could say. And then of course, since it's the last admixture, it's the last. Well, I'm Bengali, so it's not for me because I have East Asian ancestry, but that's a separate issue, and that's actually much easier to estimate because the divergence is so great. But in any case, for most Indians, that's the last major ancestry. You can actually use modern populations. So the key with like ancient DNA is you could get beyond the last major admixture very easily, but the last major admixture in your ancestry is always going to show as like a big and easy detectable signal. So you could just say like, I don't know, like tens of thousands of modern samples as well, right? So like, yeah.
Yeah, and in that context, like how does that compare to other ancient samples that we have from, say, roughly the same period of time? Is it about the same amount, or is it less?
No.
Yeah.
India's really bad. Like it's just, and it's not just because you can't do it. Look, I don't want to speak badly, but like the Indian government, like they don't make it easy. Like I'm serious. Like Pakistan makes it, like basically ancient DNA in the Indian subcontinent will probably, I have to be honest, I think it's going to be figured out in Nepal, Bangladesh, and Pakistan, not in India. There's just like no way that the government's going to enable this. I have no idea why. And yeah, but but basically it's just you have one sample from the Indian subcontinent. Like there are some samples from like Himachal and a few other marginal areas on the edges and in Nepal, but you have one sample really from the Indian mainland, and that's Rocky Gari. You have over 600 samples from Britain right now that are ancient, from Britain alone. Okay, in Africa you have now, dozens. Okay, so that's a hot area. So why is there nothing from India? It has nothing to do with the science. They just slow walk everything in biology. They've been doing this for decades. So I don't have any expectation. Like you're gonna get like like the 1,000 genome samples for South Asian people. They sampled in Lahore, they sampled in Dhaka, and then they sampled in England and the USA to get Indians. They couldn't sample in India. Okay, so this obviously causes a problem because hey, people in the diaspora are not genetically the same as people in India for various reasons. But whatever. Yeah. So there's very little. There will be very little. We'll probably figure it out with Pakistan samples.
Yeah, I had a follow up question for Razib. So, if you look at two of the components of the modern Indian population, right, the AASI and the Indus Valley cline, what is the westernmost reach of these two components among modern populations? So, do we have AASI in Iran or modern Iraqis, or how about the Indus Valley cline? Yeah.
Yeah, there's residual. There's like there's detectable Indian ancestry among Iraqis and also in Tajikistan in some samples. So some of this can just be attributed to like the Ghaznavids of that period, maybe earlier, but definitely during the Ghaznavids, there's like a massive like they took a lot of slaves. Like Al-Biruni records this, so it's at least the Ghaznavids, probably later because they're Indian merchants in places like Azerbaijan, into the medieval period. So we know that there's these Indian people. In Iraq, I haven't seen any samples that detect it, but I would assume in Basra there would be. The Persian Gulf has a residual amount of Indian ancestry even before the modern period, just because the Indian Ocean trade. So if you look at like native Qataris or native, like not people whose ancestors just migrated from the interior of the Arabian Peninsula recently, but coastal fishermen, like a lot of them have some Indian ancestry along with African ancestry, and it's because the Indian Ocean trades brought people. So there has been some Western flow. Most of it's to the Islamic period and later, I'm assuming. Although there's some attested, during during the Akkadian Empire, there were people from Malua that were living in Iraq, merchant communities. Merchant communities usually tend not to have a strong long-term genetic impact because people in cities don't replace themselves in cities and towns. It's usually rural areas that are engaging in demographic increase.
Yeah, thank you.
Rasib, what are some of the shortcomings of this method? What are some of the areas of improvement that professionals are working on? What are the blind spots of studying history the way genetics help us study history?
Well, I mean, you don't know what language they spoke because you don't have a time machine, right? If you have ancient DNA, you actually have total demographic information, right? If you have ancient DNA, it's not like so for example, there is a particular mutation on R1A Y chromosome that's found in the Altai region, in Iran and in the Indian subcontinent and Tajikistan, right? Um, and so there's been arguments about like where this mutation came from, blah blah blah. But now we have like ancient DNA from like 2,800 years ago, and it's first found in Belarusia, and it was the dominant lineage in Russia. You know, up until the last couple of thousand years, something happened. There was a major demographic turnover. Now you find like very very like random isolated individuals with this lineage there. But it used to be the dominant lineage of the indigenous cultures. Like you go in and for example the Fationovo Balanovo culture, which is basically like between Belarus and Moscow, right north of the steppe. All like most of the males tend to have this, like now you would call it Indian or Iranian Y chromosomal lineage, and it's not like a hunch. It's like you just like sequence them, and you're like, oh, they match all the mutations. Like these are the ancestors, and you can look at like what the mutations are, right? So if you have the ancient DNA, you can make perfect demographic inferences. What that tells you about the culture, well, I mean that's a whole different thing. Obviously we're speaking English. Our ancestors are, I think, not English, so language, archaeological culture, like these things can be kind of weird. So archaeologists have made inferences and theories about populations of the past, and then when people went in with DNA, they were like, oh, like this doesn't match what we expected. So obviously, prehistory is, it's an imperfect game. Like to give a concrete example, the ancient Pontic steppe had a lot of cultural diversity with like all these different archaeological cultures. Then they went in and they started like sequencing these ancient individuals from these graves, and they all look the same. So what that said is this was a genetically homogeneous region with a lot of cultural diversity. They had no idea. They assumed that it had to be genetically diverse because it was culturally diverse, right? But it wasn't. So like these sorts of things, like, you never know until you check. And there's always like a lack of, until you have like literacy, until you have like written records, there's always going to be, like lack of clarity about like identity of various groups, because identity occurs through language and cultural customs, and you can't reconstruct all that.
Right. Any comments, Mukunda, Gaurav, Shrikant?
Yeah, no. I mean, obviously, like, the studies of ancient history or ancient populations in history and culture are becoming much more, I guess, cooperative in different divisions of uh, of academia and research. So, but as Rajiv said, and I still think this is an issue that will have to be played out over time. Is We have to understand the interaction between population, cultures, languages, and communities in the ancient world, how they functioned, in whether we want to speak of them as um, basically inevitably all functioning the same at some level, or if there is a uniqueness in models. And again, my particular way of thinking about things is I tend to try to go back to first principles and look at the presumptions that are built into the various ways we think about things. And so I do find that that we sometimes we and I don't know if Razib thinks this is right or wrong, but sometimes we tend to look at data and we look at current theories and just kind of try to mesh them together as opposed to trying to go back to first principles. But maybe I'm incorrect, and people do consider other options and other premises to start from.
Sure. Razib, any thoughts on that?
Well, I mean, so the initial premise before ancient DNA, the initial premise that archaeologists made is there's population continuity, and that all of the change that they're seeing is due to I don't know, like people used to wear bell bottoms in the 70s. It's obviously that change is not they don't wear them anymore. That's actually not due to demographics, due to cultural change. So they used to think like, oh well, like they changed like this pottery style or whatever, this burial style because they have a new innovation. Ancient DNA, they started going in, look at the burials, they're like, okay, these are just totally different people, right? So it's like it's just genetically totally different. So obviously they did update their premise. So like now we're much more open to demographic like change. So for example, um, like basically when the 2009 paper came out, Reich and Patterson, I emailed Nick Patterson. I'm like, this paper seems crazy because you're saying that like 4 or 5 thousand years ago, like there was like a population mixture and like between a 50-50 mixture. And I'm just like, India had a huge population. Like, how are these things happening? And, it didn't make any sense to me. And, I actually replicated their methods and I was just like, okay, like it's actually a crazy result. I have a hard time believing it, but this is just what the data say based on these models, And so you can make some unrealistic models to make it go away, but it's just like, okay, these are crazy parameters, like crazier than the idea that there was this mixing, right? And so, and then when the ancient DNA shows up, ancient DNA basically confirmed with more precision the inferences that they were making from the models, right? It confirmed the admixture. Like, there's no step ancestor in the Rocky Gari woman. There's no step ancestry in these Indus Valley samples from Afghanistan. And there's like step ancestry detectable in 95% of samples from the Indian subcontinent today, right? So you have a total of say like 25 samples, zero step ancestry that look to be Indian or Indian origin, and then in the modern populations, 95% of people have detectable step ancestry. Like, I mean, that's just like statistically very significant. And the only inference you can make is there was like a massive admixture that happened in the last 4,000 years. You see it in the SWAT samples at low levels, 1000 BC. It keeps increasing over time into the modern period, early modern, the early ADs. And so, like, what's going on here? Like, I think the conclusion is there was a massive admixture. Where do these people come from? Well, it turns out that that 30% component that you see in, say, like a Brahmin from UP is almost perfectly matched by these, there's like about like 75 samples of people buried in northwest Kazakhstan in these Sintashta towns, these like militarized towns. And, they have 90% of them have the Y chromosome that's found in over 50% of Indian Brahmins, right? So that's where we are.
Right. So one thing I would like to add is what Razib said, that step component is found in 95% of the Indian populations. But also, I think Razib can correct me if I'm wrong, that 1500 or 2000 years ago, rigid endogamy began in India. So that must have, this mixing must have happened before that, like almost
Yeah,
2000
yeah,
years
yeah, yeah,
ago,
yeah,
right,
yeah.
Razib?
So yeah, so it's like a multi-step process. Like so, and I mean, I think the estimate that they usually give is like 1500, 1600 years ago. You start to see the high endogamy layer barriers pervasively. But like I talked to Priya Murjani, and she said, like, I mean, and like this is Vagish also confirmed this. You can see that there are like unmixed AASI probably in the Indian subcontinent 2,000 years ago in the east of the subcontinent, in particular, like Chotanagpur, that area. Like it looks like that's when the last of that mixing happened. There are no unmixed AASI left in the subcontinent, like just zero, right? But these people existed 2,000 years ago, so it was a gradual process. If you look at the Munda samples, and I have, there's some weird things with the Munda samples. One, like the Puliar, almost no step. Two, they have no R1A, like zero, which is pretty rare in Indian samples. And three, 65% of their Y chromosomes are the same as Y chromosomes in like Cambodia. So I mean, like, so you obviously have like different types of mixtures, different types of dynamics going in here. For whatever reason, there's like almost no step in the Munda samples. They're about like 25-30% East Asian, and then the rest of it is like other Adavasis in Central and South India. So when did this happen? Probably within the last 2,000 years. And that's and like I said, Bengalis, like our admixture of East Asian ancestry is quite clearly dates to about 1,500 years ago. And it's like one single wave. It's not like continuous. I mean, again, I don't understand this at all, but I actually did replicate on my own genome and other people, and it's like it's true. That's what the statistics are saying. So it is what it is.
Yeah, I had a question for Razib. How confident are we that the step ancestry that we see in modern Indians was primarily male mediated? Because when we do look at ancient DNA samples from, say, the Swat Valley, I think the finding is that it is not necessarily male mediated. Right? The Y chromosome is not R1A, if I'm not wrong. Correct me if I'm wrong.
Yeah, yeah, they're really rare. They're really weird E's. So, but within yeah, they're E's, which is not very common in the Indian subcontinent. Actually, there are some E's in Pakistan, but it's mostly a West Asian component. Actually, but in any case, yeah, in SWAT, it's kind of weird. So the inferences that you make from X chromosomes, because that's what you do, you look at the ratio on the X chromosome, because 2/3 of X chromosomes are in females, because they have two, men have one. You look at that ratio. The statistical power on those estimates is actually like not that great. I'm a little surprised, but they're not. There is some evidence that it was male mediated. I think the better, yeah, you don't need statistics. The better way to just do it is look at the Y chromosome, look at the mitochondrial DNA. So obviously, half the Syntashta samples have Y chromosomes, but they all have mitochondrial DNA. The mitochondrial DNA in the Syntashta samples, one, they don't have haplogroup M, which is the dominant one in the Indian subcontinent. So like probably like 75% of Indian subcontinental people have M. And then there's some other ones like the Harakigari woman was U2B. That's mine, by the way. And so that tends to be indigenous to the subcontinent. What they have is like W, X, T, just random things. You see it a few people. So like I actually met an acquaintance of mine who's an Ayer, and he's a W, which is extremely rare in the subcontinent. But the Santashta people, like their W's there. So in Pakistan, like I think they estimate like 10% of the mitochondrial DNA might be traceable to the Santashta people, but obviously that's considerably less than like say like the 40% that's R1A. So if you compare like the X chromosome to the Y chromosome, like basically what happened 15 years ago is some geneticists were looking at the Y chromosome and some of them were looking at the mitochondrial DNA. The Y chromosome geneticists are saying Indians are like people in West Asia and strangely Eastern Europe. And then the mitochondrial DNA people were saying Indians are like people in Southeast Asia. And so like I mean how do you resolve these? Well, how you resolve these is there's like a and you see the same thing in Europe, by the way. The Y chromosome is different than the mitochondrial DNA. Mitochondrial DNA is much more indigenous to like the Neolithic people.
That was Razib Khan. Every time I hear an expert talk about their work, I can't help but admire how we as humans are expanding the scope of our bounded rationality. I'm also reminded of what Agent K, played by Tommy Lee Jones, tells Will Smith's Agent J in the movie Men in Black. Start quote. 1500 years ago, everybody knew Earth was center of the universe. 500 years ago, everybody knew Earth was flat. Stop quote. Who knows what we'll know about genetics and our ancestors in a few years' time. Thank you for listening to this episode. In the next episode, we'll have our speakers talk about the world of Indus Valley civilization. We look forward to your comments and feedback.
Tune in next week for Brown